These are some notes for the Go of 4.6. In this section, you're asked to graph a pair of linear equations. So in this example, we're asked to graph y equals 1/3 x minus 4 and the equation 2x plus 3y equals 6. I'm going to start by graphing this first equation. So just to remind ourselves what the pieces of this equation tell us. The -4 here tells us the y-intercept. So we know that that's the point 0, -4. And the 1/3 in the equation tells us the slope. So I draw in a set of axes. I label my axes x and y. I scale them, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. As long as I have noted what one value is on the x-axis and one on the y-axis, that is scaling. Because in order to have the fifth box over B5, I would have had to count by ones. So the first thing I do is I plot my y-intercept. So that's 0, 1, 2, 3, -4. And then I follow my slope. My slope here is 1/3. So that means I go up 1 over 3, up 1 over 3, or I could go down 1 to the left 3. I connect those dots. Ideally, a ruler is very helpful here. However, it's an approximate, so graphing it freehand is fine also. For my second equation, 2x plus 3y equals 6. I could solve this equation for y, get it into slope-intercept form, and do this same process. So that's an option. A second option is to use this problem to find the x and the y-intercepts. So the x-intercept happens when y equals 0. So I can plug that in and solve. This gives me the point 3, 0. And then I can find the y-intercept, and the y-intercept happens when x equals 0. So 2 times 0 plus 3y equals 6, 3y equals 6, y equals 2. So that's the point 0, 2. So now I can plot both of those points. I will plot the first one over 3, up 0. Plot the second one over 0, up 2. And then I would connect those 2 points. I can also see here that I'm going down 2 over 3 and down 2 over 3. This is also a third point, so that can allow my line to be a little bit straighter. And we see we have 2 lines. We've graphed them. They meet at a point of intersection, so that is our answer. And that point is over 6, 5, 6, down 2.